Okay, hi everyone. Welcome to lecture 9. Today we have our second lecture about iterables. And so the C++ version covered in this lecture is in 110, 165, and 210 at DVC. Okay, so let's get started. The study goal is how to look through a list and what is a Python dictionary and list comprehension for this lecture. So let's get started. So uh, we'll talk about for loop here. For loop, we have iterations covered in the previous lecture, lecture 4, but we only talk about uh, while loop. So we have introduced another new loop, for loop, in this lecture. So let's see how does for loop work. So we learned while loop, which is actually a conditional loop, which means that every time you enter the loop, you have to evaluate some certain conditions to find out if the condition is true, I can jump into a loop, or otherwise, I will skip the loop. Yeah, so this is condition no. And today we learned about unconditional loop, which means that we don't have to evaluate conditions, um, and then it will loop. So suppose I have a list 1, 3, 2. I do for I in this, I do I plus equals 5. So this is an example of for loop. So the first thing, we have a for keyword, and then we create a variable name. So it can be anything. You can say element, you can say I. Yeah, in while loop, like you may think like in this, you may think I is an index to show the position of the element and of the members, the element or the members. But for here, create a variable name. But this name represents a single variable in the list. And suppose like I can be 1 and I can be 2 in this example. So this is I, and I can be 1 and or I can be 2. So I also have the in keyword. The in keyword is means that the variable is in the list, and at this position, um, we must have a variable which is literable here. So how does for work like? Suppose I have 1 and 3, 2, and for I is a single element that represents a single element in the loop. So which means every time, like a bookmark, you say I point I to 1, and then I'll do something here. So for example, I have I plus equals 5. So I would do uh, I equals I plus 5 for 1. And then after finishing, I will jump into another one. So this will be, I will be 3 this time. And so I'll, I'll let it be A. And then I'll jump to 2. So which is the last element of the list. So I represents every element in the list, and it will look through, like it will check and evaluate and do some operations on every element from left to right, one by one. So this is how for loop works, and we have a column behind. Yeah. So for every element in the list, it is added by 5, and you cannot stop a loop unless I reaches the end of the list. For example, I becomes 2, and there's nothing behind 2, so which means I have to stop here. Or there's a return statement is hidden in the loop. For example, if I say if I is equal to 8, and then I return the number, return 8. So at this situation, the I will not be 2. Like it will return a number immediately without actually looking into the elements behind. But of course, usually return statement is in a function. So if you type it in a global frame or interpreter, um, like a terminal, um, there's no return statement. So usually you can't stop a loop unless you hit the last element of the list. You hit the last element of the iterable. So this is for loop. So we have a comparison of the for loop and while loop. So they are basically kind of the opposite operations. Like they have different characteristics, um, although they are both iteration. So for while is conditional loop. As I just said, you have to have some certain type of conditions, and you must evaluate the condition to see if that's true or false every time you enter the loop. Like every time you did all of the operations in the while loop, um, like it seems like you may exit the loop, but you still have to evaluate to see if you still can be in the loop. So this is conditional, but for loop, um, for loop, usually the condition of the for loop is usually if the element I hit the very last element of a literable. So this is the only condition. This is the only condition for to stop. But otherwise, maybe you have something you want to stop, but you can't stop. Maybe you can set the variable I, the last to the very last element of the iterable. So for is unconditional. Like every time you enter a loop, every time you stay in the loop, you cannot control that with conditions other than uh, like setting the variable I, other like except for setting the variable I to the very last. So usually it will loop through all the members of the list. You usually um, do the same thing on every element, and you cannot stop, you cannot skip unless you do some modification. And you can have some condition to stop it or to exit. And then we will have another one is predictable. So while it's not predictable, like usually, as I for here, predictable means that how many times you're gonna loop, like you're gonna to do the same operation. For while, if I only to check the conditions, if the conditions is always true, maybe at some time, maybe 1,000 times, maybe 999 times it is false, then I will return. Like there are a lot of things like every time you come with variables with different values, but with the same condition, like you may or may not know how many times while loop can actually loop unless you do some calculation, do some thinking and induction. So, but for loop, it is predictable because it is very obvious that you will know how many times you loop because you can see maybe the length of the list as your indicator, or maybe how many times in the range. Like for each number, it represents a time. Suppose I have numbers from 0 to 99, which means a range 100, and you know that I will loop this. I will have this for loop 100 times. So, but for while loop, every time I give you different values, you cannot like the times of looping may change, but for loop, every time give you the variable with different values. The for loop will still be 100 times looping because the variables with different values cannot change. Actually, cannot change the time for loop to run because we don't have conditions to evaluate, and then it will be set as usual. So this is conditional and predictable. And then for string, string like usually string is a bunch of letters. So you have character variable in C++, and string is like a set of characters. So many letters they combine together, so they can be a string. So string is a bunch of letters, so it can be treated as a list of letters or characters. Suppose name equals the Apple Valley College. So this is a string. So the length of a string, because you can treat it as a list, like you see, oh, we have 21. 21 including the space, the backspace, including the space inside. You have 21 characters. So this is the length of the name, the string, and then I want to check out the first letter of the string. So name of 0. The 0th place is D. So return D. String. And tuple. Tuple is similar to a list, but we use parentheses. Uh, wait, we use parentheses instead of square brackets. So the data can be accessed as usual as when you do this, but you cannot modify a tuple once it is set up. So what does it mean? Suppose I have a name 1, 2 in a tuple, and then I would check name in the 0th place is 1, obviously, and name in the first place is 2. But when I do name of 1 equals 3, I want to modify, I want to delete 2 and make it to be 3. It will cause an error. That's because tuple cannot be modified. It can only be accessed. Yeah, seems like sometimes like you have some data and maybe you have the right to modify data. Maybe you don't have the right to modify data. And tuple is one of the examples that you can modify the data. You can only, if you really want to modify, you can like try to create a new one, but you can modify it on the original one. So this is tuple. Yeah. And a very popular example using a tuple is range function, or maybe a range tuple. So range, they takes in 2 values. The first value on the left side is the start and end. It will including all the integers from the starting number to the ending number, including the starting but excluding the ending number. So suppose I have range 1, 10. So it will have all the numbers starting from 1 and ending in 10, but I will include 1. But I don't have 10 here. So the maximum number in this range is 9. So I have 1, 2, 3, 4, all the way down to 9. I don't have 10, but I have 1. So this is range. So including the starting number, excluding the ending. Suppose I have a range. Range is 5, 10. So it will be 5, 6, 7, 8, 9. So you do not have 10 here. But when I only take one value, is another situation. That means that the start variable is default is set to 0. So which means that if you only type a number in the range tuple, like it will start from 0 every time, and then it will end in front of the number you type in. So for example, for range here, I have 10. So the maximum number is 9. So it will be all the integers in starting from 0 all the way down to 9. So it will be 0, 1, 2, 3, 4, 5. Yeah. So we can do a small example. So we can start from tuple. So suppose tu is 1, 2. Tu of tf1 is 2. But if you want to modify it, it will be an error because tuple cannot be modified. So then I would do what was that? I would do range. So range from 5 to 10. So maybe I can convert it into a tuple. So it'll be 5, 6, 7, 8, 9. You don't have 10 here. You can do another one. This time I don't have 10. I don't have 5. So it'll be from all the way down to 9, starting from 0. You'll include a 0, but exclude a 10. Yeah. All right. So Python dictionary is also iterable. Like every stuff we talk about here is all iterables, which means that they have very similar characters as a list. You can modify one of the elements using a loop or maybe using the positions. But for dictionary, the positions is really does not matter. That every time you want to access with the data, you use a key instead of the position. So dictionary, like we use a bracket, we have key one, key two, value two, and you have a column inside to separate key and value, and you have a column to separate each key. Like, and the key corresponds to a value. So access data with keys. The position of the data does not matter. The only thing that matters is the key. Suppose I have key two value one at the front and key one value one at the back. Oh, this should be value two. Let's check it. Uh, this is value two. Yeah. Suppose I have key two, value two at the front and key one, value one at the back. When I want to find out the value one, I do not use like position. I just use the key. Like I use the key so that I can access no matter where it is in the dictionary. So suppose I have dictionary 10A, 6B, 1C. So 10, 6, and 1 are the keys. A, B, C are the values. So I would type, oh, this is the example of a dictionary. So yeah, why is it called dictionary? Like when you think about looking up in the dictionary, you want to find out a word, and then you try to see, oh, I want to find some keyword, so that I can find the word. So the keyword of every word is like maybe starting at the front. Uh, uh, Suppose I have the word like college. So start with C and then O and then L. So that can be the key of the word. So like suppose the dictionary does not come with alphabetic order. Like maybe we start with C and then A and then B. Like does it actually matter when you try to find out? A little bit like you have to find out where C is. But once you find out where C is, like no matter which place of the dictionary, according to like you can only use a key to find out the value you want. So the order of the keys and the values does not matter. Once you find out a key, no matter where it is in the dictionary, you can find and access and even modify the data. So this is why is it called dictionary? Because we have keys. So suppose I have this dictionary. I access the with data of each key. So dictionary of one is not A. Like mathematically is in the first place, but no. Maybe this one it's not in the list. So it's in a dictionary. So for A, the key of A is 10. For B, key of B is 6. So which value using the key 1. It is C. So dictionary of 1 is C. It's neither A nor B. And it store data with new keys. Like I want to extend the dictionary, want to add something into it. So dictionary of 9 is D. So I will be adding up like the 9 column and then D at the back, and then get all the keys or data stored in the list. When you have keys, like you may have list dictionary dot keys, and then sounds like looks like it's a function, or you can just do key of list of dictionary. When you use the variable dictionary, um, although it's a dictionary object, like when you do the list of it, it will give you all the keys, but not all the values, the keys. Mhm. And values, you use dictionary dot values and then parentheses. Now you can treat keys and values, they are functions. When you use the dictionary, it will give you the keys. So demonstration. Yeah, I see. Cause one, suppose I'll get was it invalid? Um, I'll try again. Okay, and then uh, we want to find, we want to expand dictionary. Suppose I have 9. Dictionary is 1A, 10B, 8C, 9D. Like I extend the dictionary, and then I would do final keys. Yeah, keys equals list of DIC key. Key is in the like I make the dictionary into a list, so it returns the values instead of the. I return the keys instead of the values. So which is actually have to know about it. And when I want to do values, I do values and list of dictionary dot. So at this time, when I put all the values of a dictionary into list, I'll get all the values of the dictionary. So this A, B, C, D, and this 110, 8, 9. These are keys and these are values. We do list of dictionary. Uh, you will have all the keys. Okay. So list comprehension. So actually you want to create a new list um, based on another list, want to create a list based on another iterable. And you create a new list by looking into every element in an iterable item individually. Like you want to modify or want to filter out some elements in an iterable item and then put all the stuff you think they are good into a new list. So how you're gonna do that? Mm, Suppose I have the list O 1, 2, 3, 4, and it's a new list which is an empty list. So if for I in O, you if it is an even number, like if I mod 2 is equal to 0, so new dot append I times 5. So you may like for here, I actually do like want to check out every element in the O list. There are 1, 2, 3, and 4, and I want to check them individually to try to find out which numbers are even numbers. Once I found it out, I do not store them in the original type. I want to times everyone by 5 and then store it into a new list. So maybe you can do this. It's actually real okay. But I also have another new idea of doing all of this, and this is called list comprehension. So suppose I have old, 1, 2, 3, 4. So I can do new is I times 5 for I in old if this one. So the format of list comprehension, I can do this just in one line using this is the new equals um like we already know that we can create a new variable name called maybe also element to represent every element that we're going to look through in the list. So usually we have for I in old. O is a list. So I represents every element in the O list that I'm going to look through individually from left to right for everyone. And I is the same here. So I times 5 means that I will modify every element of the old list, and then I'll store it in the new type. And as usual, we have for I in old, and then I also have an if. I have an if statement is to filter out because I only need even numbers. So I'll filter out all the odd numbers. So when I do if I mod 2 is equal to 0, which means that when I have 1 and 3 here, I do not times them by 5. I do not times them by 5. Like I have to abandon them. The first thing like for when I look through in the old list, I will check if this even. It's not even, I'll skip. If that's even, I will times it by 5 and then put them into the new list. And then for new list, I'll get uh, 10 and 3. So this is list comprehension. Comprehension means that you have to understand how it is being created. So this is the meaning of comprehension. So list comprehension is that I use a concept, or maybe I use a method so that I can filter out or copy like some certain part, or maybe I will modify the elements from a list, and I have to check and modify every element from the list using a same concept, using a same comprehension. And then I will put them into a new list. So each number of the new list, each element of the new list is modified, and you understand how they're gonna come, like how they come. So this is called comprehension. So this is list comprehension. We also have dictionary comprehension, but we are not gonna talk about it here. So this comprehension is very useful. We will talk about trees later, I guess in 2 weeks, and then this comprehension will be very, very useful for recursion, used in recursion. Yeah. So, and then I will have that. Oh, let's see. For every element in the O list, if individual mod 2, like if a single element mod 2 is even, and then I will append the product to the individual um and the product of individual times 5 to the new list. So yeah, so I will look for old, find out if the even number is even, get times them by 5 and get them into the new list. So I comprehend how this is created, how the new list is created. So, and then I will do functions with this. I will introduce 5 functions that can use to modify or to find out some results using list. So, okay, any and all functions. Any functions returns false if all elements in the list is a false value. All elements in the list are false values, or else you return true. So like any means that I want to find anything that is true. So once I get something, like I have a bunch of stuff and one of them is true, and then I return true. So any and all functions returns a Boolean value. Only returns true when there's something inside is true. Otherwise, you return false. So for any false, false, true, I will return true. Or you do any of false, 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 it will only return false. So any means that I want to find something that is true. So all function returns true if all elements in the list are true field values, or else you returns false. So all function means that I want to check if everything in a list are true. If one of them is false, then I will give you a false. So all false, false, true. Oh, I yeah, false, false, true. That means I return false. So every time as it is like the thing we did in the first lecture. So for any, I want to check if that's true. If that's not true, I'll skip. So this is like operator. This is like operator. And to check if that's false, um, this is false, but I want true. So I will still skip, and then I will have hit the true, and then I return true. And all is like and. So once I hit this is false, I don't have to look into them. So this is false, and then I return false. This is actually called short circuit evaluation in computer science. We didn't have that concept. I just lately discovered that it is called short circuit evaluation. So once I get this is false, I don't even have to look into other things in the list. So this is any and all function. And I have a map function. Map function takes in another function and a iterable, and then apply the given function to every element in the old iterable item, like for example a list, and then returns map object containing a new list uh, with all the outputs. I think it's containing another new iterable, and then you can convert it into a list or a tuple. Yeah. So you can think about the distribution law in math. Suppose I have A of B plus C. I will become AB plus AC. So it's the same thing in math function. So you treat like think about function abstraction. Like I know the function name, so I use this function. I know it's a function name. I use it as a tool without knowing how it actually works, and I can use it to apply the function onto other items. That means I treat some values as the input of the function, and then it return something according to the function algorithms. So yeah, map of function, and then I have a list. It will becomes function of element one, function of element two, function of element three. So which means that distribution. Uh, this will return the output of the function by taking element one into the function, and this is like also return an output by taking into element two, and this is the same. Yeah. So I have example here. So you have add one, like suppose it's a lambda function. It actually works. So lambda one, add one is lambda x plus one. And I have an object. This is called a map object. Yeah, return a map. Map, and then add one is the function. And then I have a iterable list. And then add one, and then a list. And then I get the object. And I want to check what's the thing inside the object, and then I can convert it into list of the object, and then you have 2, 3, and 4. Because I have 1, 2, 3, and then every number plus one will be 2, 3, 4. So this is the meaning of map function. You can try it though. I can use in the tuple or something. And one is uh object. Maybe I can find other stuff like mal 5. Or just taking mal 5. And then I will have a list, A7, A9. And then object is a map object. I can convert it into lists to see what's inside in there. And then it would turns out to be a list. And with 40, how does 40 come? I have 8 and I apply mul 5 on A, so it would be 40. And it is 35, 80, 45, 35, 45. Yeah. So maybe I can convert it into a tuple. Haven't thought about it. Oh, it's empty. Oh, I guess that's because you're taking a list instead of a tuple. Maybe try do it. Suppose I'm having tuple here. So yeah, this time convert it into a tuple. You're taking a tuple and you only returns a tuple. You can only convert it into a tuple. How about this? Oh, empty list. Yeah. So this is map function, and I have maximum and minimum function. Maximum function returns a number that is like greater than any other elements in the list. So it returns the maximum value of a list. Suppose I have a maximum of 1, 2, 5. It returns 5. Minimum do the same, do the opposite thing. I find out the minimum value in the list. So maximum, minimum, and I also have sum. Sum returns an integer though, like it returns the sum of the element in the list. Suppose I have 1, 2, 5. So I'll get 1 plus 2 is 3, 3 plus 5 is 8. So I'll return 8. Sum is like, yeah, sum is like adding all the elements together and then return the sum. So these are 5 functions of the with list, and the all, map, and max, min, sum. Oh, it's 6 actually. Yeah. Okay, so we can do an example here, do a practice. So use recursion to merge two lists and make them ascending order. So I use maximum or minimum function and use recursion. I will have defined merge list, this one, this two. I have an example. Suppose A is, oh, okay, A is the result of this. So I take in 4, 3, 2, 1, and 101, 99, 98, 0. And every time I have this list. Oh, every time I have this list, suppose I have 4, 3, 2. Suppose 1, 99, 100. Every time I want to merge, I have a new list, and then I'll find out, like I'll check all the numbers in the two list to find which is the smallest. I'll find, okay, suppose this is this two, and the above is this one. So I'll check, oh, the one is the smallest, and then I delete that. Then I will check another thing, like the second smallest, like because I'm doing the ascending order. So the smallest is 2 in this one, so I get it rid of, and then I will have 3, and then I will have 4, and then I have 99 and 100. So this is how two lists merge together and then make them ascending order. Ascending order. So we use maximum or minimum function. So let's try it. Yeah, think about it. With I guess you can try it in 5 minutes or 10 minutes. Yeah, you can try in 5 minutes. Yeah. Can use max or min function. Or maybe I can just get started, like analyze the problem. So let's get started to analyze the problem. So Suppose I have Visual Studio. I have first list. Those A's merge and then and 1, 9, 28, and so A is okay. So, uh, okay. So we can start thinking about the problem. Um, so okay, because I'm doing ascending ascending order, so which means that every time I have to find out um I have to find out the smallest number. Have to find out the smallest number of the two lists, and then I will compare them to try which one is smaller. So suppose you have for this example A. So how to find out the first smallest? So I will get the smallest of two. So the smallest of this is 1. The smallest of that is also 1. Wait, I have 0 here. Yeah. So this is 0. And then yeah, I will check out this two, which is smaller. So this is 0 is smaller. So if I have a new list, I would say the first one would be 0, and then I will remove this, and then I will check them. I'll find out the smallest of this one again and check, oh, they're same. So we can append them. Yeah. And then we'll find out the smallest of the new after removing the even smallest. So we have 2, we have 98. And then I'll take this, remove it, and append them until I get all of them, or maybe one of them is empty. Yeah, we can add one of them is empty. So the answer is yeah, suppose wait. Hmm, okay. Suppose I'll find out the smallest one, like S1, smallest of the first list. So I'll get minimum of this one. S1 will be this one. S2 will be minimum of these two. And then I'll compare them, start comparing them. If S1 is less than S2, so which means that I will do the recursive call here. Return merge this. Suppose I have this one, this two. Okay. So I'll see. Okay. What will this return? This will return everything that is correct after S1. So this is the list S1. And this will also return the list. But this time I have to eliminate the S1 though. That's because I want to check after removing that, I want to check the second smallest. So I have to remove the first smallest, and then the second smallest will be the first smallest in the list. So which means that I will do S1 or this one. So I'll remove S1. So then that will get removed. The first smallest will get removed. So that the second smallest will be the second smallest will be the first smallest. So otherwise, yeah, this two dot remove S2. This includes when S1 and S2 is equal. So return S2 plus merge this S1 S2. So I'm actually creating a new list like for here, and I can modify S1 and S2 because I don't need to keep them to the end of my result. So this is how they do. But we found that actually this only works when you have two lists. They are actually um, with the same lengths, but we don't have the same lengths. The first list we have the length of 4, and the second one we have the length of 5. So that is not enough for us to solve the problem. So we have to think about that when maybe either one of the lists will be empty. How are we going to? So suppose this will be the recursive, this will be the base case. We have done the recursive call and aggregation. Like we have the recursive leap of faith by assuming that merge lists. When I do list one dot remove S1, or when I do list two dot remove S2, it will return a correct list right after the smallest one we append into the list. Suppose this one suppose we have run into this. So suppose this is S1. This will be the one, and the merge list S1 S2 will be every correct stuff at the back of it. Yeah. So but for now we have to think about maybe either one of the lists will be empty. So suppose this is empty. How are we going to do? We can't just append these two though, because they are not in ascending order. So still do the same thing. Like I'll find as the smallest because we don't have to compare. Smallest of wait. Smallest of minimum, and then because this one is empty, so we just do that two. So yay, and then do recursion. Yeah. X then plus let's do this one and this two. And before doing that, still get this two remove and the smallest number. Yeah. So this is when this one is empty. So How about how about this two is empty? As if this two is empty. As the biggest minimum. This one. This one dot remove S, and then still do this. Also return this stuff. Yeah. So and for the stuff there, if else is everything other than these two. So we'll put all of them below else. What if this one and this two will be the same and empty? Suppose they are both same empty. I'll say if this one is empty and this two is empty. So return empty is, yeah. Oh, this can be this is the still the recursion, like recursive call, but this one is the base case. For why this, like, even though one list is empty, maybe we have another list which is not empty, and we still remove the smallest one from them and then append them, and then yeah, to when both are empty, we have to find out the base case for this. This is a base case, and you just return an empty list because there's nothing there though. Like, does it make sense? Yes, because we do plus. Like, when something plus nothing, it'll be still be something. Like, there's no effect on that. Like, you don't have list, nested list or something. No. Yeah. This is extend instead of append. So we can check it out. I don't think you can check it out here. We can try oh, let's see what happened. Incorrect indentation. Okay. Where is it? In it's not iterable. So line 1, line 25. Okay. 18. This is this one, this two. Sorry about that. Yeah, check. Okay, we do this. So we found out they are same. Yeah, they are same here. So which means this works out. So we have to think about uh when they are like they are not empty, how we gonna do? When one of them are empty, how we gonna do? And both of them are empty, still, how we are gonna do? So yeah, thanks for today's lecture, and this is the answer of it. So when this one is two is they're both empty, return empty this. So one of them empty, one of them empty. You say another one, you still have to find out the smallest of them and then append them to a list because we are not doing ascending. They are not ascending lists. So We do return as merge list. This one is two. I guess actually we have a built-in function sort. We can sort a list, so we don't have to do so many recursions. But without knowing that, because I didn't teach you that, so you can use this. Yeah, although it'll be a bit lower efficient. Yeah, and for list two is empty, like do this one. Like you can sort that out and then to append that and else. And else you have to compare. You have to compare the smallest numbers between these two lists and to find out the smaller one. And then you remove that, and then next time you can find the second smallest one, and then to try to compare that, and you do that. So you eventually have this. Okay, thanks for today's lecture, and this is the end of the lecture. Okay, okay, have a nice night.